So if you've ever even thought about working with data in Python, you've definitely heard of Pandas. It comes up all the time. In this explainer, we're going to pull back the curtain on it. We'll get into exactly why it's the undisputed champ for data analysis, walk you through getting it set up, and then we're going to get our hands dirty and actually build and inspect your very first data set from the ground up. But let's start with a really big question, right? I mean, there are thousands of Python libraries out there. So how did this one, Pandas, become the absolute go-to tool for pretty much everyone working with data? Honestly, if you can understand the why behind it, mastering the how becomes so much easier. So here's our game plan. First, we'll tackle the big why. What problem was Pandas even designed to solve? Then we'll break down its two core building blocks, the series and the data frame. After that, it's all hands-on. We'll get your environment set up, create that first data frame together, and then wrap up by learning the 3 essential checks you should run on any new data set you get your hands on. All right, let's dive right into section 1, the why. Before we write a single line of code, let's really get a feel for the fundamental problem that Pandas solves for us. Why does it even need to exist? So at its heart, Pandas is all about what we call structured data. And that's just a fancy term for anything that fits nicely into a table, with rows and columns. Think about a spreadsheet or a database table. Before Pandas came along, you might have had to write these really clunky, complicated loops just to do something simple, like read a file and find an average. Pandas just turns that into a single line of code. It's designed to make these tasks fast, intuitive, and, like the quote says, expressive. And the reasons to use it are just incredibly practical. It makes complicated things feel simple. Need to read a CSV file? That's one command. Got messy data with missing values? It has awesome built-in tools for that. Slicing up your data, filtering it, combining tables, it's all surprisingly straightforward. And maybe the most important part, it's a team player. It works beautifully with other essential libraries like NumPy for heavy-duty math and Matplotlib for making charts and graphs. Okay, so now that we know why Pandas is a thing, let's look at what it's actually made of. To really get good with Pandas, you just need to get your head around its 2 fundamental pieces, the series and the data frame. Pretty much everything you do is going to involve one or both of these. First up, we've got the series. And the absolute easiest way to think about this is just a single column from a spreadsheet. That's it. It's a one-dimensional list of your data. But it has a kind of superpower. Every single value has a label attached to it, called an index. This makes looking up data and matching things up incredibly fast and really, really efficient. And here it is, the star of the show, the data frame. This is the main tool you are going to be using 99% of the time. Just think of it as the entire spreadsheet, a whole 2-dimensional table. It's size mutable, which is really just a fancy way of saying you can add or move rows and columns super easily, and it's heterogeneous, which means you can have a column of numbers right next to a column of text, next to a column of dates, all living together happily in the same table. And if you only remember one thing, let it be this analogy right here. If you can picture an Excel spreadsheet in your mind or a table from a database, you already get the fundamental idea of a data frame. It's the perfect mental model to keep in your head while you're working. This table just lays it all out perfectly. A series? It's one-dimensional, one column, and holds only one type of data. A data frame? It's 2-dimensional, can hold lots of columns, and can mix and match data types. But here's the real key insight. A data frame is really just a bunch of series, all lined up next to each other, sharing the exact same index. That's the secret. All right, theory is great, but let's get practical. Before we can start doing all this cool data analysis, we've got to make sure Pandas is actually installed and ready to go in our programming environment. Getting this set up is super, super simple. If you're using a standard Python setup, you'll use the package manager called pip. Now, if you're using a data science distribution like Anaconda, you'll use Conda. And honestly, a lot of the time, if you have Anaconda, Pandas is already pre-installed for you, which is nice. Okay, once it's installed, you have to bring it into your script. And the universal, community-wide convention that you will see everywhere is to import it with the alias PD. It's just a nickname, right? It saves you from typing pandas over and over again, and it just makes your code way cleaner and easier for others to read. Okay, our environment's ready. We've imported pandas. Now for the fun part. Let's actually create our very first data frame. While most of the time you'll be reading data in from files, it's so important to know how to build one right from scratch.
One of the most common and, I think, intuitive ways to make a data frame is from a standard Python dictionary. It's simple. The keys of the dictionary, those become your column headers. And the values, which are lists of data, they become the rows within those columns. It's just a really clean, straightforward way to map an idea into code.
Now, another really cool way you can do this, as you can see here, is by building a data frame from a list of dictionaries. In this setup, each dictionary represents a single row in your table. The keys are the column names, and the values are the data for that one specific row. This method is super useful when your data is coming in one record at a time. And, to really hammer home that idea we talked about, that a data frame is just a collection of series, you can literally build one by making individual series objects first. Let's take a look at what that actually looks like. Yeah, this visual just makes it so clear, doesn't it? We create a name series and a team series totally separately. Then we just pop them into a dictionary, and Pandas is smart enough to automatically line them up using their index to create this perfectly structured two-column table. It just goes to show you that deep down, a data frame is just a clever collection of series. Okay, so you've got Pandas installed, you've even made your first data frame. So, what now? Well, before you jump into any kind of crazy analysis, there's an essential three-step checklist that basically every data analyst runs to get a quick feel for a new dataset. Think of this as your initial recon mission. It's a simple, but man, it is a powerful three-step process. You take a little peek at the data, you check its overall size, and then you review the technical structure. Let's break it down. First thing, you're always going to want to use the head method. This shows you the first 5 rows of your data frame by default. It is the perfect sanity check. It tells you, hey, did my data load correctly? Are the column names right? Do the values look like what I expected? Next up, use shape. Now, notice there are no parentheses here. That's because it's a property of the data frame, not something you do to it. And it instantly gives you back a little pair of numbers, the number of rows and the number of columns. This gives you a sense of the scale of your data set in less than a second. And last, but honestly, maybe the most important of the 3 is using the .info method. This gives you an amazing technical summary. For every single column, it tells you the name, the number of non-missing values, which is absolutely critical for finding holes in your data, and the data type that Pandas assigned to it. This is your first step in any data cleaning task. And that's really it. In just a few minutes, you've learned how to get Pandas installed, you've grasped its core concepts, you've created a data frame from scratch, and you've run the first critical checks of any data analysis. You now have the foundational skills to start your own data journey. So the only question left is, what are you going to discover?